Hey everyone, it's Kabir Bhutto from OCEA. In the previous lecture, we talked about moment of inertia extensively, and we calculated moment of inertia about the centroidal axis for this rectangular shape, about this axis as well as this axis, and they were coming out to be equal to Ix dash was equal to bh cube divided by 12, and Iy dash was equal to hp cube divided by 12. So in this lecture we are going to talk about parallel axis theorem. What is parallel axis theorem and why do we use it? So let's say you want to find moment of inertia about an axis which is parallel to this centroidal axis. So if I want to find moment of inertia about this axis which is parallel to the centroidal axis, let's name this axis as x, which is passing through the base of the rectangle. In that case, I'm going to use this parallel axis theorem. So let's assume that the distance, perpendicular distance between the two axes is dy. So in that case, moment of inertia about this axis is going to be equal to Ix equals to Ix dash, that is this value, plus a dy square. So a here is the area of the cross section, and dy is nothing but the perpendicular distance between the two axes. Take the square of it and multiply this with area and sum it up with the moment of inertia about the parallel centroidal axis. You'll get your moment of inertia about this axis. What if I want to find moment of inertia about this axis when the axis is passing through this edge of the rectangle? And let's name this axis as y. And let's name the perpendicular distance between the two axes as dx. Well, in that case, moment of inertia about this axis, Iy, is equal to Iy dash, that is moment of inertia about the centroidal axis in vertical direction, plus area into dx square. You just take the square of this distance and multiply it with area and sum it up with the moment of inertia about the centroidal axis. You will get your moment of inertia about this axis. Now let's apply this parallel axis theorem to polar moment of inertia, that is the moment of inertia about an axis which is perpendicular to x dash y dash plane as well as passing through the centroid. So let's say if I want to calculate polar moment of inertia here at this point, so what I will do is I'll calculate this distance. Let's name this distance as dx. I will calculate this distance as well, and I will call it as dy. And let's call this distance as d. So d from here, if I apply Pythagoras theorem, it's equal to d square dx square plus dy square. So polar moment of inertia about this axis is equal to j about the centroid. Polar moment of inertia about the centroidal axis plus a d square, where a is the area of cross section and d is the perpendicular distance between these two axes, this one and this one. Okay, let me move this here. And so what does parallel axis theorem say? The moment of inertia about an axis is equal to the moment of inertia about the parallel axis passing through the centroid. So these are the moment of inertias about the centroidal axis. So let me put a bar here which denotes them that they have to do something with the centroid, plus the product of area and perpendicular distance between the axes, which means that this term. Now let's do an example related to parallel axis theorem. So the question here says that determine the moment of inertia for the rectangle with respect to axis xp passing through the base of rectangle. That is, we have to determine moment of inertia about this axis which is parallel to the centroidal x-axis. Okay, from the previous lecture we know that Ix dash is equal to bh cubed divided by 12. So Ix dash. And now we are going to use parallel axis theorem to determine moment of inertia about this axis. So moment of inertia about this xp axis is equal to Ixp is equal to Ix dash plus a dy square. And dy in this case, the perpendicular distance between these two axes is equal to h by 2. And let's substitute the values. Bh cubed divided by 12, area is equal to bh, and dy here is the perpendicular distance, which is h by 2 square. And if you simplify it, so the moment of inertia about this xp axis is equal to bh cubed divided by 3. So we have question number 2, which says that determine the moment of inertia for the rectangle with respect to axis YA shown in figure. So you have to determine moment of inertia about this axis, which is passing through this edge of the rectangle YA. Try to solve this question on your own and post the answer in the comment section. If you are able to do it, it's good. If not, no problem at all. I'll share the solution in the next video. Thanks for watching till the end and take care.